Hello, and welcome back to the Cosmic Companion. In this week's episode of Astronomy News with the Cosmic Companion, we welcome Dr. Matija Ćuk, a research scientist at the SETI Institute. We will be discussing his recent discovery that Mars may have been accompanied from time to time by systems of rings. But first, we'll look at a new study suggesting the universe is expanding faster than it should be according to theory. And we travel to a solar system with 4 very different worlds. We explore how dust on alien worlds can affect the development as well as the discovery of extraterrestrial life. Since the Big Bang, the universe has continually grown larger. The rate at which space expands is one of the critical values astrophysicists need to understand the cosmos. Now, expected values for this rate produced from theoretical physics are significantly slower than what is consistently observed by astronomers. Now, a new study utilizing an international array of radio telescopes has added further evidence to these experimental findings, suggesting that the standard model of the universe, which tells us about the history and the future of the cosmos, may need to be revised. The B1298 star system, located roughly 350 light-years from Earth, is home to at least 4 planets. A new study of these worlds suggests the 2 closest to their star likely lost much of their atmospheres as they were bathed in massive doses of X-rays from their young star. These infant worlds are now likely large balls of bare rock, the study found. The outermost of the 4 planets is likely a gas giant, something like Saturn. But the physical nature of the 3rd planet remains a mystery. It may be a warmer version of Neptune, but the mass of that world, and consequently its physical structure, remains unanswered. Planets which orbit too close to their sun can be caught in a gravitational lock with their parent star, in much the same way as the moon always faces the same side toward Earth. These conditions would heat one side of these worlds while leaving the other in an eternally frozen night. A new study from the University of Exeter shows that if these worlds are dusty enough, particles carried in their atmospheres could cool the warm side of the planet while also acting as a blanket on the icy side, moderating temperatures around the globe. Now, potentially, this could increase the chances of finding life on these planets. But, however, the same dust which moderates temperatures there can also hide chemical signs of life, such as methane, that astronomers could look for in the search for extraterrestrial life, making finding life on those worlds difficult. We are pleased to be joined today by Matija Ćuk of the SETI Institute. He recently conducted a new study showing that Mars may have been adorned with a series of rings in its distant past. This week on Astronomy News with the Cosmic Companion, we are happy to welcome Dr. Matija Ćuk, a research scientist at the SETI Institute. He has done recently done a recent study of showing that the red planet Mars may have once had rings. Welcome to the show, Matija.
Thank you.
Thank you. So can you tell us a little bit about what we see Mars today and the moons that it has?
Yes, so Mars has two very small moons, Phobos and Deimos. Phobos is larger and closer to Mars. An interesting thing about Phobos is that it rises in the west and sets in the east. It's so close to Mars that it goes around Mars faster than Mars spins. And that leads to the strange behavior in the sky. But it has another consequence in terms of its orbit. Because it orbits so fast, Mars is trying to slow it down, and in the process, Phobos is spiraling in. And in a couple of tens of millions of years, it might come too close to Mars, and probably it won't make it all the way to the surface and hit, but might get pulled out into a ring at some point. So that was the starting point about thinking about Martian ring in the past, because there probably will be one in the future.
That's interesting. And you said it's to be a few million years from now?
Tens of millions of years, but still it's about 1% of the age of the solar system. So that's soon as these things go.
So do you think that Phobos and Deimos then are the products of past rings?
Well, they have orbits that are very close to the equator of Mars in terms of orbital plane. And that's a dead giveaway that they formed from some kind of disk around Mars. We see the same thing with the moon satellites of Jupiter, Saturn, Uranus, not so much Neptune, that's an interesting story, but that planets that have rings around them at their formation, then get satellites that are in the plane of the equator, usually. And so long time ago, when Phobos and Deimos formed, the first time, there was definitely a disk. We call it if it's just close to the planet, we call it a ring. If it's way bigger, we call it a disk, but it's the same thing, kind of. The question is, since then, over the age of the solar system, did Mars have ring at different times? And this research we did seems to indicate that, yes, it did have at different times a ring.
So then, by consequence, it had other moons as well.
Yes. So there are different ways of dealing with Phobos falling in soon. It seems like awful coincidence that we're just seeing the end of one of the two moons of Mars. But then you realize if there were moons closer in than Phobos at formation, they would have fallen in a long time ago. So maybe this is just the last of the bunch. That's one way of thinking about it. But my colleague David Minton, who's a co-author on our study, has pointed out a couple of years ago that, well, okay, if these past moons existed and they fell close to the planet and then formed a ring, rings form moons. It's not just one-way street. We see that at Saturn's rings, that at the outer edge of the rings, new moons form and get pushed away by the ring. Mm-hmm. And there is a reason to think that moons that might have started out closer into Mars originally were more massive, because if the material in the orbit that Phobos and Deimos formed from came from some kind of collision, typically the collisions throw much of material not very far and little bit material very far to form Deimos, because its orbit is kind of big. So we started thinking that, oh, maybe it's not just one-way street. Maybe the inner moons, Phobos and maybe others before it, were not just coming in, maybe they were bouncing, coming in, going out, because when there is a ring, they can also move out. And that the past moons were not different from Phobos. They were just its grandparents. that you can have this ring moon cycle where, okay, the first big moon, first time it fell to close to Mars and formed the ring, it would have formed a smaller moon, which would move away from the ring, but eventually the ring would disappear. It's giving its orbital energy to the moon, and then the ring will fall to the planet. But without the ring, the tidal forces of Mars want to pull the moon inward. So there's this cycle. Moons get pulled inward, form a ring when they're too close to the planet to hold themselves by their own gravity. But the new ring forms and pushes away a small new moon. And Dave Minton said that there may be 5 or 6 or 7 such cycles in the history of Mars. And Phobos is just the latest and the smallest of these moons. That's the big picture.
Yeah. Speaking of big picture, does that mean is the scale around Mars large enough to have encompassed intricate grooves and rings and shepherding moons and that sort of thing that we see around Saturn, or is Mars just too small for that to happen?
It probably was. It all scales, kind of.
Right.
Everything would have been smaller, but the gravity scales down. So yeah, if you scale down everything, it probably did have spiral waves in those rings, because that's how the moons and rings interact. So they would see interesting features. What is different between Mars and Saturn is that Saturn is, apart from being squished at the poles, is very symmetric.
Mm-hmm.
So the ring around it is very beautiful, like flat and doesn't have any bumps from Saturn's gravity. Gravity field of Mars is just messy because it has volcanoes and craters and it's generally a bit lumpy. So this ring would be a little bit thicker and less beautiful than that of Saturn.
So, generally, Saturn's rings have been known since the time of Galileo. Then rings were discovered around Uranus, Jupiter, Neptune, between, 77 and 84 or whatever. So we generally think of ringed planets as being the giants, the gas giants, the ice giants. But this is new to think of rings going around rocky planets.
Yeah, but not completely new, because we found some minor planets, including dwarf planet Haumea in the Kuiper Belt, and also the minor blob body Chariklo, which is a centaur. So that is a comet-like object, but much larger, to have rings. That has been found in the last few years. So that was kind of a surprise. So Mars is somewhere in between. It's not quite an asteroid, but it's not a giant planet either.
Mm-hmm. Right. So I guess that's my point, is it just the mass? What makes it more likely for rings to form around giant planets as opposed to the smaller rocky terrestrial planets?
Well, one thing you need is some kind of orbiting material. You need moons or something like that. And Mercury and Venus don't have any moons right now. And our moon is pretty far from Earth. So you need to have a little bit of material hanging around. So the moons want to move away. So it's a complicated mix of how fast this planet spins, how big the moons are, what's in the planet. Because moons of Earth want to run away because of its oceans that are pretty efficient in driving tidal evolution of the moon. So you'd need to have all this material and have to keep it close to the planet. So it's a complex thing, and the giant planets vary a lot in how much of the rings they have. Saturn's rings of Saturn are enormous and beautiful and relatively massive, and those around Uranus or Neptune or Jupiter are just dust. Yeah, so it varies a lot. There is no there is a lower end where rings don't exist anymore, and that has to do a little bit with solar radiation that removes dust particles. So that that's why we don't see dust coming off Phobos right now forming a ring. Probably it's losing a little bit of dust now and then, but the sunlight removes it faster than it can come off Phobos. So it's pretty clean in the orbit around Mars.
So do you think that it's common that rings like these may have formed around exoplanets, around planets around other stars?
Yeah, probably there are plenty of them with rings, but so far, the ones we know best are the ones very close to their stars, just because we are looking for transits and eclipses. And as I said, radiation can remove small particles. So the ones we are seeing are probably the worst bet for rings. Like once we start finding the ones further out, probably there'll be more rings out there.
Mm-hmm. And of course, one of the theories for how the moon formed was that the proto-Earth was struck billions of years ago by a Mars-sized object that kicked up a lot of material, forming the moon. Is it possible that the Earth may have had a ring at that time?
Yes, but it's a very interesting question of what this structure around Earth looked like. It had lots of mass and it was extremely hot because it was ejecta from the impact. So in Saturn's rings, you have solid ice particles. They're cold, and then they're just dominated by gravity, so they can fall into the midplane. Gravity wants to make them flat, and nothing is really fighting it. But if you have lots of gas and hot stuff in the mix, it wants to go away, go up. So you have more of a donut than a ring at that point around Earth as Moon was forming. And it's, despite being so close to home, it's one of the hardest astrophysical objects to model that we found out, because it's kind of one of a kind and really messy on the part gas, part solid, some liquid, so really messy.
Interesting. So what's next in your study of the Martian rings?
Actually, this paper, so I gave you the big picture for the Mars ring moon hypothesis. What this small paper, it's kind of short thing that's abjad letters. What we found is that the orbital tilt of Deimos, so that Deimos is not exactly in the plane of Martian equator, but tilted by 2 degrees. And if you look at orbital dynamics, that's quite a bit. 2 degrees doesn't sound like much, but it's very hard to tilt orbits without very specific conditions to do so. And the only clean way we can think of tilting Deimos is to have one of the past inner moons of Mars move outward and enter so-called orbital resonance with Deimos, where the inner moon's orbital period was 1/3 of that of Deimos. And then we could have pushed Deimos out a little bit through this lock in the resonance and tilted its orbit. And computer simulations turned out beautifully, but the crucial part of the whole story is that this moon had to be more massive than Phobos and had to move outward. And that had to be because of the ring, because the tides would want to move it inward. So that kind of confirms this hypothesis about cyclic moons and rings of Mars beautifully. So that was very nice to, you have a hypothesis, but then you put it in a computer and you get really nice results for something else.
That's great.
From the same assumptions, yeah.
All right. It's wonderful. Well, thank you very much for being on the show.
Thank you.
It's great having you. And that was Dr. Matija Ćuk of the SETI Institute. Next week on Astronomy News with the Cosmic Companion, coming June 23rd, we welcome Tyler Gorda of the Department of Physics at the University of Virginia to the show. We will talk about his work discovering the newest state of matter, quark matter, which could make up large portions of some neutron stars. Astronomy News with the Cosmic Companion will then take a 2-week break as we move into new, larger, permanent studio space. There will be no show for the weeks of June 30th or July 7th. The show will return on July 14th for the start of our 3rd season. Season 3 of Astronomy News with the Cosmic Companion begins with a surprise special guest. Tune in on next week for the guest announcement on June 23rd. Please stay safe, stay healthy, and keep your wonder alive. If you enjoyed this episode of Astronomy News with the Cosmic Companion, please download and share the episode on YouTube, Facebook video, or on any major podcast provider. For more details on space and astronomy news, please visit thecosmiccompanion.com or thecosmiccompanion.net.